Noche cósmica.
Imagine standing at the edge of absolute stillness, not the quiet of an empty room on Earth, where you might still hear the hum of distant traffic or the breath of wind against a window, but the silence that exists between worlds, the kind that seems to press against your ears with a gentle, patient weight. Around you spreads an expanse of pale, frozen terrain, ridged and fractured like the skin of something ancient, something that has endured eons of slow, relentless pressure. The ice beneath your feet is not smooth, but wrinkled and scarred, crossing in delicate patterns that seem almost deliberate, as though carved by an invisible hand over millions of years. Above, the sky is black, not the black of night as you know it on Earth, where darkness is softened by starlight and the glow of distant cities, but a profound, complete black, because there is no atmosphere here to scatter what little light reaches this far corner of the solar system, and yet the sun is there, impossibly distant, diminished to something like the brightest star visible from Earth's darkest deserts. It hangs in that black void, casting just enough light to define the edges of the frozen world, to make the ridges throw tiny, sharp shadows, to give the landscape dimension and depth. You stand in this half-light, this twilight that never becomes true dawn, and you sense something beneath you. Not through sound, there is no sound here to travel through the vacuum, but through intuition, through a kind of knowing. Below the ice, far below, exists an ocean. Liquid water, warmed by heat rising from deep within, churning slowly in the dark, indifferent to the cold above, indifferent to the infinite silence pressing down upon it. This is Europa. This small moon, orbiting a gas giant so vast that its storms alone could swallow entire planets whole, has captured the imagination of scientists and dreamers alike for centuries, though for most of human history we did not know it existed at all. And perhaps you have caught yourself wondering about such places, about the strange hidden worlds that circle distant planets, about the quiet mysteries they guard. If that curiosity draws you, if the thought of returning to these slow, patient journeys through Europa's ice and ocean speaks to something in you, consider subscribing, so that we might explore together the most relaxing facts about this moon and the profound questions it asks about our universe. But for now, let us begin at the very beginning. Let us travel back through time, not to the moon itself, but to the moment when a human being, peering through one of the first telescopes ever made, caught his first glimpse of something he could not have known would transform our understanding of the cosmos forever. If you find yourself drawn to these kinds of slow, patient explorations, journeys into the quiet corners of our solar system where ice and darkness hold their secrets close, where the questions we ask about distant worlds become, in a way, questions about our own place in the universe, then you might consider staying with us. We are building a library of extended soundscapes and documentary narratives focused entirely on Europa and the mysteries surrounding it. Each one unfolds at the pace of genuine wonder, without hurrying toward conclusions, without the bright noise that usually accompanies astronomy. These are journeys for deep evening listening, for those hours when your mind begins to release the day and can drift more freely through landscape and fact and possibility alike. What we are offering is not a quick summary or a glossy overview. It is instead something closer to what you might experience if you were to spend time, real, unrushed time, learning about a single moon, a single ocean, locked beneath kilometers of ancient ice, a single place where scientists and dreamers alike have begun to wonder whether life might exist in forms we have never encountered. Each narrative we create is designed to move with the rhythms of your own descent into sleep, to let information settle like snow, to build a kind of intimate familiarity with these distant territories. The stories we tell go deeper than the headlines. They linger with the contradictions and uncertainties. They sit with the poetry of discovery, alongside the precision of measurement. And they do so in a way that seems to calm rather than excite, to invite reflection rather than demand answers. If you have sensed, in these opening moments we have shared, that there is something genuinely soothing about learning slowly and deeply about a place like Europa, something that feels restorative in a way that most information delivery does not, then this invitation is for you. You can find these extended explorations wherever you listen to long-form audio. Subscribe to our channel so that as we journey together through Europa's ice shell, down toward its hidden ocean, through the theories and detections and quiet speculations about what might live in its depths, you will have them there, waiting whenever you need them. Whenever the world feels too loud and you need to travel somewhere distant and still. And so, with that thought gently placed, we can return now to the deeper darkness, to the far side of Jupiter's orbit, to the pale cracked surface of that small moon that has captured so much of our scientific curiosity and our imagination. Now, imagine standing on that pale moon's surface, if you could bear the cold. What would dominate your sky is not the distant sun, that small, pale disk we know so well from Earth, but something far more commanding, far more ancient. Jupiter hangs above you, not as a star or a distant point of light, but as a colossal sphere of churning orange and white and deep brown, so vast it fills perhaps a quarter of the heavens. Its presence is not subtle, it is gravitational weight made visible. From Europa's vantage, Jupiter appears roughly 10 times larger than our moon appears from Earth. But size alone does not capture the reality of its dominance. This is a world of storms. The Great Red Spot alone has been raging for at least 350 years, a cyclone so immense that 2 Earths could fit inside it with room to spare. Those are not metaphors, those are measurements. The storms rotate with a rhythm older than human civilization, eddies and spirals of ammonia ice and complex chemistry, all churning in perpetual motion, all visible as bands of color across the giant's face, reds and oranges and whites, dark belts and light zones, all swirling in an eternal, hypnotic waltz. But beyond the visual splendor lies something more fundamental, more intimate to Europa's existence. Jupiter's gravity is relentless. It is not a gentle pull. It is a constant, rhythmic, kneading force that shapes everything orbiting nearby. Europa is held in place by this gravity, yes, but more than that, it is being continuously deformed by it. As Europa traces its elliptical path around Jupiter, completing one orbit every 3.5 Earth days, the giant's gravitational grip tightens and loosens with each revolution. At some points in that orbit, Europa is closer to Jupiter. At others, it drifts slightly farther. The difference is measured in thousands of kilometers, and yet, Jupiter's gravity responds to those changes. The tidal forces, the differential pull across Europa's diameter, flex the moon's rocky interior, heating it from within through friction, through the constant, patient deformation of rock and ice. This is a subtle but profound reality. Europa is not a cold, dead world slowly cooling in the darkness. It is being actively heated by the world it orbits, by the gravity of the gas giant that dominates its sky and controls its fate. Imagine, for a moment, an object being gently squeezed, then released, then squeezed again, in a rhythm so steady and so ancient that it has become the pulse of the moon itself. The other Galilean moons, Jupiter's large famous satellites, share this space around the giant, but Europa occupies a unique position. Io, the innermost of the 4, experiences tidal heating far more intensely. It is a world of volcanoes, of molten surfaces, of sulfur compounds that paint its landscape in yellows and reds and blacks. Ganymede, the largest moon in the entire solar system, orbits farther out, in a region less turbulent, less violent. And Callisto, the outermost, seems ancient and geologically quiet, its surface scarred by impacts accumulated over eons. But Europa sits in a middle realm, not so close to Jupiter that it boils, not so far that it freezes into complete dormancy. It is, in some sense, in a Goldilocks zone of its own, a region where tidal heating is strong enough to sustain processes within, yet gentle enough to allow a stable surface. On Europa's surface, from that hypothetical vantage point, you would see day and night as we understand them. The sun does rise and set, though weakly, for Jupiter itself reflects light and creates a dim twilight even on the night side. But the passage of time is marked not by the distant sun alone, it is marked by the passage through Jupiter's shadow. As Europa orbits the giant, it plunges into eclipse regularly, into a darkness that is nearly complete, broken only by the faint glow of Jupiter's atmosphere and the distant starlight. And then it emerges again, into sunlight, into that pale illumination that barely warms the ice. Each orbit brings this rhythm: light, shadow, 3.5 Earth days from one midnight to the next. The radiation environment around Jupiter is intense and complex. The giant has a magnetic field of its own, a powerful, dynamic field that traps charged particles from the solar wind, creating belts of radiation that would be lethal to unshielded human explorers. But Europa exists within this field. The radiation shapes the chemistry of its icy surface, creating chemical reactions that might otherwise never occur. It is a harsh environment, and yet it is an environment that has persisted in this form for billions of years, unchanged in its essential character, a steady-state environment where ice meets radiation meets gravity in an ancient dance. This is the context in which Europa exists, not isolated, not alone, but embedded within a system of forces, gravitational, magnetic, thermal, that define its nature. Jupiter is not backdrop. Jupiter is the reason Europa is as it is. The giant's shadow falls across the moon constantly, and within that shadow, far from the warmth of the sun that lights our world, processes continue in the darkness. Processes we are only beginning to understand. In the winter of 1610, in Italy, a man named Galileo Galilei turned a simple tube of glass and metal toward the night sky. It was not the first telescope ever made. Others in the Netherlands and elsewhere had already crafted these strange devices, but Galileo's hands had refined it, sharpened it, and more importantly, he possessed both the curiosity and the courage to point it at the heavens when the Church held firm beliefs about what the heavens ought to contain. That January night, when he aimed his telescope at Jupiter, something extraordinary happened. The great planet swam into focus, banded with clouds and storm, but that alone was not what froze him in wonder. Around the planet, where the dark sky should have held only emptiness, 4 small points of light became visible. 4 tiny moons, orbiting Jupiter in graceful circles. He watched them night after night. They danced around their host planet with mathematical precision, appearing, disappearing, reappearing. Some nights they would vanish entirely, passing behind Jupiter's bulk or into its shadow. Other nights they would emerge again, faithful as clockwork, as though they had never left. The constancy of it, the mechanical beauty of it, must have filled him with a profound sense of witnessing something true and deep about how the universe actually worked, not how anyone had been told it worked. This discovery shattered a centuries-old assumption. For longer than anyone could remember, the Earth had been thought to sit at the center of everything, with all celestial bodies orbiting around it in perfect, unchanging harmony. Yet here was proof, visible through a telescope, that at least some bodies in the sky orbited not the Earth, but Jupiter, a planet that was itself not at the center. This was not merely a new observation. It was a seismic shift in human understanding, though it would take decades and centuries for the full weight of it to settle into the minds and institutions of the world. Galileo named them the Medicean stars, after his patrons, a gesture that mixed genuine discovery with the politics of patronage that kept a scientist fed and safe. But history would come to call them the Galilean moons, and they became four of the most studied objects in the solar system. There is a quietness to their names now, names drawn from Greek and Roman mythology. Io, Europa, Ganymede, Callisto, four sisters and cousins of the gods, cast as moons orbiting their king, Jupiter. Consider for a moment what it must have felt like to be Galileo in that moment. The cold night air, the telescope steady in his hands, the gentle ache of one eye pressed against the eyepiece. The moment when the blurred chaos of ordinary vision suddenly crystallized into clarity, and he saw, truly saw, four new worlds. Not speculation, not mathematics on parchment, actual light, reflected from actual bodies in actual space, traveling through that immense darkness and entering his eye. The universe had suddenly grown larger, more populated, more strange, and it continued to exist. It continued to move and revolve, whether he watched it or not. What sustained him in those nights of observation must have been something like the same wonder that fills astronomers even today when they catch first light from a new discovery, the sense of being present at a threshold, of knowing something that only moments before was unknown to humanity. It was a solitary form of knowledge in a way. Before the telescope, the moons did not exist for human eyes. They existed, certainly, circling Jupiter through the void, but they were utterly unknown, utterly absent from the human story. Galileo changed that. With a simple instrument and patient attention, he brought four new worlds into the light of human awareness. And though he could not have known it, though no mind in 1610 could have imagined it, one of those moons, the one that would come to bear the name Europa, would eventually become a place of profound scientific fascination, a world of ice and hidden ocean, a place where the deepest questions about life and water and the origins of biology would eventually come to rest. But that knowledge lay centuries in the future, waiting in the slow accumulation of technology and understanding. For now, in this moment we inhabit as we rest with Galileo's discovery, there is something essential about the sheer simplicity of wonder. A man, a telescope, the sky, and the sudden revelation that reality was far stranger and far more beautiful than anyone had known. The four moons swung through their orbits night after night, indifferent to the revolution they had sparked in human consciousness. And in that indifference, in that perfect, mechanical continuation of their paths, there was perhaps a kind of peace. They had been moving this way for billions of years before anyone was there to see them. They would continue moving this way for billions of years after every human who ever lived had returned to dust. The universe, it seemed, was far older and far more patient than the institutions that tried to govern the interpretation of it. When the German astronomer Simon Marius observed those four dancing points of light around Jupiter in the early 1700s, he found himself reaching backward through time, searching for names that might carry weight and meaning among the stars. The moons were given titles drawn from classical mythology, each one a figure from the distant, dreamlike world of the ancient Greeks. But there was something particular about the second moon from Jupiter, the one that orbited between Io's volcanic fury and Ganymede's massive shadow. Marius chose to call it Europa. The name itself carries a kind of softness, doesn't it? A resonance that seems to suit a world of ice and concealed waters. Europa was a Phoenician princess in the old stories, a figure whose life became entangled with fate and transformation in ways that feel almost inevitable when you hear them unfold. The myths have a way of echoing across centuries, and this particular myth has something in it that speaks to Europa the moon as well as Europa the legend. In the ancient telling, she was the daughter of Agenor, a Phoenician king, and she lived a life of ordinary royal privilege until the moment everything changed. Zeus, the king of the gods, caught sight of her as she walked with her attendants along the seashore, gathering flowers in the manner of carefree young women who have no idea that transformation lies waiting just beyond the horizon. And Zeus, as the stories go, was struck by her beauty with the force of inevitability. But he knew that his wife Hera, the queen of heaven, watched his actions with terrible jealousy. So he did what the gods often did when they wished to move undetected through the mortal world. He disguised himself. He became a white bull, pure white, spotless, gleaming in the Mediterranean sunlight, like something that might have descended from the realm of divinity itself. The creature was gentle, almost meek in its appearance, and when Europa saw it emerge from the waves, she felt no fear. Instead, she was drawn toward it with a kind of curious affection. She reached out and touched its white hide. The bull made no aggressive movement. It allowed her to drape garlands of flowers across its back, and when she playfully climbed onto its back, still thinking it merely an unusual and docile animal, the transformation of her life accelerated in a single moment. The bull turned toward the sea and walked into the waves with Europa clinging to its neck. Out beyond the sight of her panicked attendants, out across the vast expanse of the Mediterranean, the bull carried her. The journey was long and disorienting, a crossing between worlds that felt to Europa like a kind of abduction, though the bull moved with a grace that was almost tender. When they finally reached the far shore, on the island of Crete, the bull revealed himself. Zeus stood before her in his full divine form, and Europa understood then that she had been chosen, though not asked. She had crossed from her ordinary life into mythology itself. The myth unfolds from there with that peculiar logic of ancient stories, where violence and tenderness, choice and fate, become almost indistinguishable. Europa bore children in that distant land. She became the mother of kings and heroes, and though her name was attached to a continent, to the land where she had been carried, she remained always in the stories a figure caught between worlds, between her old life and a new one that was not of her choosing, between mortality and the touch of divinity. There is something deeply resonant in this myth when applied to the moon that orbits Jupiter in profound silence and cold. Europa the princess crossed an ocean, leaving everything known behind. Europa, the moon, orbits in the outer darkness, separated from the sun by the vast bulk of Jupiter, receiving light as a kind of reflection rather than direct illumination. She, too, exists in a kind of threshold space, in a region that feels somehow removed from the warmth and familiarity of the inner solar system. And beneath her surface, hidden from all direct observation, lies another ocean, a sea that Europa the moon carries within her, just as the mythological Europa carried the weight of her transformation and her displacement within her. When you contemplate the choice of this name, it feels like something more than mere astronomical convention. The scientists and astronomers who decided to call this moon after a princess who crossed oceans, who was carried away to distant lands, who existed in a state of profound change and separation from everything she had known, perhaps they understood something about the moon itself. Perhaps they sensed that this world of ice and hidden depths, this small pale sphere orbiting in Jupiter's shadow, deserved a name that carried within it the resonance of journeys, of concealed transformations, of mysteries that lie just beyond the surface. And so the myth and the moon became intertwined, not through any scientific necessity, but through the deep human impulse to tell stories, to find meaning in the patterns we observe in the cosmos, to give voice to the quiet places of the universe by connecting them to the narratives that have shaped human imagination since the beginning of consciousness. The name Europa carries both the princess and the moon, both the old story and the new one we are still learning to tell. Now, if you were to stand on that small moon and measure it, you would find something like this. Europa stretches only about 2,470 kilometers across, a diameter that feels almost modest when you consider the immensity surrounding it. To place that gently in your mind, it is smaller than our own moon, yet larger than the planet Mercury. Imagine, if you will, a sphere of ice and rock, only slightly smaller than the luminous body that tugs at Earth's tides. And then imagine that sphere nestled in orbit around something so vast, so heavy with gravity and presence, that standing anywhere on Europa and looking up would show you the horizon entirely filled by Jupiter's clouded, striped, eternally turning face. The distance between Europa and Jupiter's center is a number that repeats in the literature with a kind of gentle insistence. 671,000 kilometers separates them. Try to hold that in your mind, without strain, without effort. It is a distance across which Jupiter's gravity reaches down and squeezes, kneads, stretches. It is far enough that Europa remains in orbit, yet near enough that the pull never quite relaxes. If you were to travel from Jupiter's cloud tops straight down to Europa's icy surface, you would journey through a darkness so profound that the few photons of sunlight reflected from the distant sun would barely illuminate your way, and all the while Jupiter itself would loom overhead, a presence so immense that it would seem to curve around you. The orbital period, how long Europa takes to complete a single journey around Jupiter, is 3½ days, 3 days and 12 hours. In that short span, while you on Earth would barely adjust to a new rhythm, Europa traces its path through the void in an elegant, unchanging circle. The moon keeps one face always toward Jupiter, a phenomenon called tidal locking, which means that Europa's rotation and its orbit have synchronized into a kind of eternal waltz. There is a side of Europa that perpetually faces Jupiter, receiving its light, feeling its gravity's full attention, and there is a far side, the night side, forever turned away. The days and nights of Europa are not divided by the sun's movement through the sky, but by its slow migration across an ice-bound horizon that never changes from the same fixed point. These numbers, the size, the distance, the period, can feel abstract when first encountered, but imagine them together and they begin to compose something almost musical, a small world held at a precise distance, circling with unwavering rhythm. If you were to shrink yourself infinitesimally small and place yourself on the ice, you would feel the heat of that tidal friction beneath you, warming the world from within. You would see Jupiter turning in your sky, a great marbled sphere that never sets, never rises, but simply rotates in place, its bands of color shifting endlessly across your horizon. The sun, by contrast, would be a point of light so distant that it would seem almost irrelevant, more a memory of warmth than a source of it. What makes these measurements remarkable is not their size alone, but what they imply about the forces at work. Europa is small enough to be shaped and molded, yet substantial enough to maintain an entire ocean beneath its crust. It orbits at a distance that places it in Jupiter's radiation belts, in a region of space where particles stream past at nearly the speed of light, yet it remains protected by Jupiter's magnetic field from the worst of the solar wind. It circles with a period so quick that it completes 4 full orbits while you sleep deeply for 8 hours. These vital statistics, these simple numbers, describe a world in perfect balance, held in a kind of gravitational cradle where change happens slowly, rhythmically, with the patience of something that has circled the same path for 4 billion years. And in that constancy, in that measured rhythm, there is something profoundly settling. The numbers tell you that Europa is stable. It is not careening wildly through space. It is not spiraling inward toward its parent world, or drifting outward into the cold dark. It is, instead, in precisely the right place, moving at precisely the right speed, for a small moon to maintain its character, its hidden ocean, its thin exosphere of oxygen, its strange beauty. The statistics are, in their way, a lullaby of proportion, a gentle assurance that in the vast and often chaotic universe, some things remain constant, measured, and deeply, deeply peaceful. Through the long centuries between Galileo's first telescopic glimpse and the age of spacecraft, Europa remained a pale ghost in Jupiter's shadow, known but not truly seen. What scientists could gather came through the patient work of spectroscopy, that gentle art of reading light itself, of understanding what a distant world whispers through the colors it reflects back toward us. In those middle decades of the 20th century, long before spacecraft could draw close enough to touch the moon with their instruments, astronomers began to notice something peculiar about Europa's light. When sunlight bounced from its surface and traveled across the vast gulf of space to reach our telescopes on Earth, something in that reflected glow held a secret. The light carried a signature, a fingerprint written in the language of wavelengths and absorption patterns, and when those patient researchers studied that signature with growing precision, they began to see the unmistakable mark of water ice. This was not merely speculation or educated guess. The spectral evidence was becoming clear. Europa was not a dark, barren rock like so many moons are. Its surface was bright, far brighter than one might expect from bare stone or dust. That luminous quality, that pale, ethereal sheen, could only be explained by the presence of water in its frozen state. Ice has a particular way of scattering and reflecting light, a kind of clean, pure reflection that speaks to the composition of the surface in a language older than words. What made this discovery so remarkable, so quietly profound, was what it implied about the nature of Europa itself. If the surface was ice, then water, that most essential molecule for life as we understand it, was not merely some distant possibility on this moon. It was present, it was real, it was literally what one would see if standing on that distant, cold landscape, stretching out across a vast expanse of frozen material. But here is where the story deepens into something more mysterious still. Scientists began to wonder, in those thoughtful moments between observations, what lay beneath that icy crust. The brightness of the surface told them about the composition, yes. The spectroscopy confirmed the ice. But the very existence of that ice raised a more tantalizing question. Was this merely a thick, unchanging, ancient coating on a dead world? Or was there something more dynamic, something churning and moving beneath? The early measurements of Europa's reflectivity became part of a larger puzzle. When combined with observations of the moon's unusual surface features that would become far more visible when spacecraft finally arrived, scientists began to construct a narrative that was far more complex than a simple frozen sphere. The ice shell, it seemed, had a certain smoothness in some places that spoke of relative youth. In other regions, there were patterns and cracks that suggested movement, that hinted at forces working from below or within. There is something deeply moving about how light itself became a messenger across the void. Photons that had traveled from the distant sun, bouncing off Europa's ice, journeying millions of miles through the darkness of space to strike the lenses of Earth-based telescopes, carrying with them the story of a world no human had yet seen with their own eyes. Each wavelength absorbed or reflected was a whisper of information, a small voice calling out across the cosmic distance. The brightness of Europa, that pale luminescence that distinguished it from so many other moons in our solar system, became the first real clue that this was a place fundamentally different from what people had imagined. It was not merely another cratered satellite waiting passively in the darkness. It was a world covered in something that spoke of water, of ice, of processes that might still be unfolding in the deep interior. Consider for a moment what this revelation meant to those scientists working in their observatories, gathering spectral data night after night. They were learning that millions of miles away, there existed a frozen ocean world, or at least a world with a frozen surface that might be hiding something far more substantial beneath. The ice was reflective, yes, but what was its depth? How thick was this shell? And most tantalizingly, could there be liquid water beneath? These questions hung in the minds of researchers through the 1960s and into the early 1970s, as the age of space exploration was rapidly accelerating. The spectroscopic evidence had painted a portrait in shades of white and pale blue, the colors of ice, the signature of water. It was an invitation, a gentle beckoning toward a world that would reveal itself more fully only when machines could be sent to cross the gulf between worlds and arrive at Jupiter's court. The early light-based discoveries were, in many ways, the scientific equivalent of a bedtime story being told in whispers. There was wonder in those findings. There was mystery. The ice shell of Europa, revealed through the patient reading of reflected light, became the first confirmed piece of a much grander architecture that would slowly unfold in the decades to come. It was the foundation upon which all future understanding would be built, the knowledge that here, in the Jovian system, there was indeed a world of ice and water waiting to share its secrets with those curious enough to listen. It would take more than 3 centuries for humanity to look again at what Galileo had seen through his crude lens. The telescope improved, the world changed, and by the 1970s, when spacecraft began to move through the solar system not as theoretical dreams, but as actual machines hurtling through the dark, Europa was waiting in that same quiet orbit, unchanged, patient, wearing its mysteries like a silk veil across frozen stone. The first real seeing began on December 7, 1973. A spacecraft called Pioneer 10, which had already traveled farther from Earth than any human invention ever made, swept past Jupiter and its moons in an encounter that lasted only hours. As it arced through the Jovian system, its cameras turning toward the small pale moon, something extraordinary happened. Europa, which had been a featureless star-like point in every telescope ever trained upon it, suddenly revealed itself. The photographs came back, broken into pixels, grainy by today's standards, but to the scientists gathered in the control room, they were like first light breaking across a landscape that had never been seen by human eyes before. There was texture, there were features. There was the undeniable proof that something lay on that distant surface, something to be deciphered. What they saw was deeply strange, and that strangeness would shape our understanding of Europa for decades to come. The surface was smooth, impossibly smooth. In an age when astronomers expected the moons of the outer planets to be battered and cratered like our own moon, carved by billions of years of impact, Europa appeared almost pristine. There were craters, yes, but they were few and shallow and seemed somehow softened by time or by some process that had been gently erasing them. Where other moons were scarred and pitted, Europa wore the face of something that had been renewed, something that had healed itself. But it was not unmarked. Running across its icy surface in long, delicate lines were cracks. Not the jagged breaks one might expect from sudden fracture, but lines, long, linear scars that seemed to map out a hidden conversation between the moon's surface and whatever lay beneath. Some of these lines were faint and subtle. Others were bold enough to span the width of continents. They spoke of tension, of something moving beneath, of ice being stretched and released, generation after generation. Pioneer 10 gave us only a glimpse before it passed onward into the outer solar system, its mission nearly complete. But the glimpse was enough to change everything. Enough to make scientists realize that Europa was not simply a dead rock floating in darkness. It was telling a story through its surface, and scientists began to lean forward in their chairs, hungry to read more of it. Within a few years, between 1979 and 1980, two more spacecraft arrived. Voyager 1 and Voyager 2, these twin emissaries, came much closer than Pioneer 10 had managed. They carried better cameras, better instruments, a more curious gaze. And when they looked at Europa, they confirmed what Pioneer had hinted at and added layers of detail that deepened the mystery. The photographs from Voyager showed that the smooth surface was dotted here and there with what would come to be called chaos terrain, regions where the ice seemed to have been jumbled and broken and refrozen, creating a landscape of icy blocks tilted at odd angles, as if something had stirred the frozen surface from below and then let it settle. There were ridges that rose and fell in gentle waves. There were streaks of darker material running across the brightness, material of unknown origin, perhaps minerals brought up from the deep interior, perhaps the marks of ancient geological processes. What struck many observers most powerfully was a simple fact. Europa had almost no large impact craters. Our moon is a palimpsest of cosmic violence, its face written over again and again by billions of years of meteor and asteroid strikes. But Europa seemed to have been wiped clean. Not completely. There were some craters, but the absence of the expected abundance was profound. It suggested something that sounded almost impossible. It suggested that the surface was young, geologically young. Not young in human terms, perhaps 100 million years old at the surface, still ancient by Earth standards, but young in cosmic terms, young enough to imply that something was constantly refreshing it, some process, some mechanism, some hidden movement in the moon's depths. The cracks remained the most haunting feature. Scientists began to map them, to name them, to study their patterns. These linea, as they were formerly called, often ran for thousands of kilometers across the surface. Some appeared to be ancient, crossed and recrossed by younger linea in more or less parallel lines. Others seemed fresher, more recent. Together, they created a visual language that suggested tremendous stress and strain, the kind of stress that would arise if the ice shell were being pulled apart by forces within. They suggested that the solid surface was not stable and unchanging, but dynamic, active, alive in some fundamental sense. When Voyager 2 passed by, its instruments detected something else. Europa's magnetosphere, the region around the moon, influenced by its own or by Jupiter's magnetic field, seemed to behave in ways that suggested the presence of something conductive beneath the ice. A salty ocean, perhaps, or liquid water, something that could conduct electricity and interact with the magnetic environment. It was a subtle signal, easily missed, but it was there, a whisper of evidence that would echo through the decades to come. The Voyager photographs, analyzed again and again by teams of scientists in the following years, painted a portrait of a world that was not dead, but potentially alive with slow, grinding, hidden processes. The smooth face, the linea, the chaos terrain, the low crater count. All of these elements suggested something that challenged the assumptions of planetary science. A moon should not look like this. A moon should show its age. A moon should be stable and unchanging, its surface a frozen record of its past. And yet Europa seemed to be something else entirely, something that was constantly being remade from within, something that had secrets. And those secrets, barely glimpsed in those pixelated photographs from the 1970s, would draw humanity's gaze back to that distant, icy world again and again, each time with deeper instruments, each time with more refined questions, each time with a growing sense that beneath that smooth, cracked surface, something extraordinary might be waiting. What the Voyager cameras revealed was something far stranger than scientists expected. The surface of Europa was not rugged or cratered like Earth's moon, but instead smooth, pale, and crisscrossed by an intricate web of long cracks. It was as if the moon had been frozen solid, then gently fractured again and again, without ever fully breaking apart. How could a small world so far from the sun maintain such a strange, active-looking face? The answer lay not in any external violence, but in something invisible, relentless, and happening deep inside. Imagine for a moment the pull of gravity as a kind of hands, not violent hands, but patient, rhythmic ones. Jupiter, that immense sphere of gas and storm, does not hold Europa in a simple, unchanging grip. Instead, Europa orbits within the domain of other moons, and their combined gravitational dance creates something called orbital resonance. Europa's orbit is not perfectly circular, but slightly elliptical, stretched and compressed by the patient tug of Jupiter and its sibling moon Io, which orbits closer to the giant planet. 4 times during each complete journey around Jupiter, Europa swings closer, then farther away, and with each approach and recession, Jupiter's gravity squeezes and releases the tiny moon like a hand gently kneading bread. That kneading motion penetrates all the way through Europa's interior. The solid rock and ice that make up the moon are not perfectly rigid. They flex, they bend and shift with each cycle of approach and retreat. Imagine holding a rubber ball and squeezing it repeatedly, releasing, squeezing again. The friction generated inside the ball creates heat. Now imagine doing this not once, but thousands and thousands of times across billions of years, on a scale so vast that the heat source is distributed throughout an entire world. This is tidal heating, and it is the key to understanding why Europa is not the cold, geologically dead sphere that distance from the sun would suggest. With each compression, the interior rocks rub against one another. The mechanical energy of Jupiter's relentless pull is converted into warmth. Not dramatic, violent warmth, but a patient accumulation of heat that works like the slow metabolism of the moon itself. The heat does not come from radioactive decay alone, though that process too contributes to the warmth of most moons and planets. Instead, it comes from pure gravitational manipulation, from the way one massive object's presence can reshape and energize another far smaller one. This heat does not remain locked in the depths, it rises. Warm material from deep within Europa's rocky interior drifts upward through the interior, while cooler material descends. Convection, that same gentle circulation that causes warm water to rise in a heated pot, moves the thermal energy outward. Some of that heat reaches the boundary between the rocky layer and the ice above. The ice, though solid and cold on the surface, begins to soften and move. In places where the heat flux is greatest, the ice may actually melt, creating pockets of liquid water within an otherwise frozen shell. And here is where the picture becomes truly remarkable. Early calculations suggested that tidal heating should be enough to sustain not merely a thin layer of melted ice, but potentially an ocean, a body of liquid water, kept liquid by the slow radiance of gravitational friction, trapped beneath an ice ceiling that seals it from space. The concept seemed almost too elegant, too unlikely, that gravity itself, acting with infinite patience across hundreds of millions of years, could sculpt the interior of a moon into something resembling the conditions for life on Earth. The physics is well understood, has been tested and refined through observation of other moons in our solar system. Io, Europa's nearest sibling, is the most volcanically active body we know of, its surface constantly remade by eruptions driven by tidal heating so intense it melts rock. Other moons show signs of the same process, operating at lower intensities. Europa's situation lies somewhere in the middle, we believe, hot enough to create liquid water, but not so hot as to completely melt the ice away. The precise balance of heat generation and heat dissipation in Europa's interior remains something scientists continue to refine with mathematical models and comparative study. What makes this form of energy production so compelling is its invisibility and its reliability. The sun's energy fades with distance. It has barely any influence on Europa's surface temperature. But Jupiter's gravity does not weaken. It does not flicker or dim. Day after day, orbit after orbit, the gravitational kneading continues. The cracks and ridges visible on Europa's frozen surface may themselves be evidence of this hidden churning. Fissures and fractures caused by the stresses of tidal flexing, by the ice shifting in response to internal heat, and the violent reorganization that occurs when water refreezes and expands. The landscape is a testament, though we read it imperfectly, to the invisible mechanics working in the darkness below. And so we drift forward through the decades, leaving behind those first grainy images from Voyager, those strange hints of something working beneath the surface. The world turns. Technology advances quietly in laboratories and clean rooms. Scientists study the data they already have, asking it new questions, turning it over like a smooth stone in their hands, feeling for new textures. And then, in 1990, the Galileo spacecraft begins its long journey toward Jupiter, a patient messenger carrying instruments that would listen in ways the earlier probes could not. Galileo would arrive at Jupiter in 1995, and what made this mission different, what gave it a particular kind of power, was not speed, but patience. The spacecraft did not merely pass by, it would orbit. Again and again, over 8 long years, it would trace careful paths around the great planet, diving close to its moons, then pulling away, then returning. Each orbit was an embrace, a slow encirclement that allowed instruments to gather data in ways a fleeting encounter never could. Imagine the difference between walking past a sleeping person and learning everything about them in a glimpse, and instead sitting quietly beside them for hours, noticing how they breathe, how the light changes across their face, what they hold in their hand. The Galileo mission carried something called a magnetometer, an instrument so sensitive it could feel the whisper of magnetic fields. Jupiter's magnetosphere, you see, is immense and chaotic, twisted and shaped by the planet's violent rotation. But within that wild dance of plasma and charged particles, there is a quiet geography. And as Galileo flew past Europa again and again, its magnetometer detected something peculiar. The magnetic signature changed in unexpected ways. The data suggested, quite gently at first, that something beneath Europa's icy crust was moving. Something was conducting electricity. Something was stirring. Deep inside Europa, the scientists began to reason, there must be an ocean. Not a frozen sea, but liquid water, salty water, moving water. It was one thing to suspect this from theoretical models of tidal heating, to work it out on paper and computer screens. It was quite another to feel it whisper through the instruments, to see it confirmed in the very fabric of Europa's magnetic field. The magnetometer was essentially detecting the signature of a conducting fluid, and that fluid could only be salt water. Fresh water would not behave the same way. But there was more. Galileo also carried a gravity instrument, something that measured the precise pull of Europa's mass, the slight variations in how its gravity reached out toward the spacecraft. Gravity, you understand, is shaped by what lies within. If Europa were solid ice all the way through, the gravity would be distributed in one way. But the measurements Galileo sent back suggested something different. The mass distribution seemed to indicate that below the icy shell, the interior was less dense than it should be if it were all solid rock. That discrepancy pointed to one explanation: a layer of water, much lighter than rock, occupying the space between the ice and the stone below. Each pass was another whisper of confirmation. The data accumulated slowly, patiently, like snow falling on a winter night. Scientists studied the readings, checked and rechecked their calculations, looked for alternative explanations, and found that they kept returning to the same conclusion. Beneath the 13-kilometer thick shell of ice that we see from space, there is an ocean. The water may be between 50 and 100 kilometers deep. It touches the rocky interior of Europa. It has been there, scientists now believe, for the entire history of the Moon. It has been there, in darkness, beneath a crust of ice, for billions of years. There is something almost overwhelming about this knowledge, isn't there? To recognize that something so vast, so fundamentally alien to our surface experience, has been present all along, unseen, unknown, right there, in the visible solar system, where we had been looking at it all along. The ancient Voyager missions had flown past without seeing it. Only when we sent an instrument sensitive enough, patient enough to linger and listen, did Europa finally whisper its greatest secret. And what Galileo suggested, through its slow and careful measurements, was not just the presence of water, it was possibility. Where there is liquid water, where there is chemical energy from the interior meeting that water, where there is time stretching back billions of years, there is a potential for something more. Not certainty, you understand, never certainty, but a kind of soft opening, a door left just slightly ajar. And so beneath that smooth and fractured ice, scientists began to imagine something that changed everything about how we understand this distant moon. For decades, Europa appeared to be merely a frozen shell, cold, barren, locked in silence at the edge of the solar system. But the magnetic readings from the Galileo spacecraft whispered of something deeper. The measurements of gravity, the subtle warping of Jupiter's own magnetic field as it passed through this small moon, suggested the presence of something liquid, something that moved. Picture, for a moment, the impossible architecture of Europa's interior. Above lies that ice shell, perhaps 10 to 20 kilometers thick in places, a ceiling of ancient frozen water scored with cracks and ridges. But below that ceiling, the calculations began to suggest, lies an ocean, a vast ocean of liquid water, perhaps 100 kilometers deep, sitting atop a rocky core. The sheer volume of this hidden sea may exceed all of Earth's oceans combined, and yet it remains invisible to any telescope, shielded by kilometers of crystalline ice. How could such an ocean remain liquid in the profound cold of space, at a distance of 700 million kilometers from the warming glow of our sun? The answer lies in the relentless embrace of Jupiter itself. Even as the great planet rotates in the darkness of space, its gravity exerts an eternal pull on everything that orbits within its sphere of influence. Europa, small and patient, completes its circuit around Jupiter every 3.5 days. But Jupiter's gravity is not uniform across the Moon's surface. The side facing the planet experiences a stronger pull than the distant side. This difference, this tidal force, stretches and kneads the Moon like dough in invisible hands. With each orbit, Europa is bent and twisted, flexed and released. The interior rock moves, the material shifts, and friction generates heat. Immense heat, concentrated deep within the Moon's rocky mantle. It is a process so slow, so patient, that it unfolds across billions of years, yet it is powerful enough to keep an ocean liquid in the heart of frozen darkness. This is tidal heating, one of the most elegant mechanisms in planetary science, and one of the most soothing to contemplate, for it speaks of transformation through persistence, of warmth emerging from constraint. That subsurface ocean would not be the pristine, crystalline water of Earth's pure mountain streams. It would be salty, it would be laden with dissolved minerals leached from the rocky mantle below. Salt and potassium, and other compounds that have been slowly dissolving into the water across eons. In this way, Europa's hidden sea would resemble Earth's own oceans far more than one might expect. And this resemblance becomes even more striking when we consider what might exist on the ocean floor. On Earth, in the deepest reaches of the Pacific and Atlantic, where sunlight has never reached, where the pressure is almost incomprehensible, there exist vents. Hydrothermal vents, they are called. At these vents, superheated water rich in minerals emerges from cracks in the seafloor, reaching temperatures that would instantly boil water at the surface. These vents create an environment so severe, so hostile to ordinary life, that for decades, scientists believed nothing could survive there. And yet life does. Not the familiar life of photosynthesis and sunlight, but life powered by chemistry itself. Extremophiles, creatures that thrive in darkness and heat and chemical abundance, that derive energy from the minerals flowing from the Earth's interior. Europa, too, almost certainly possesses hydrothermal vents. As water percolates through cracks in the rocky mantle, heated by tidal friction, it dissolves minerals and emerges into the ocean above as a warm, mineral-rich plume. The chemistry of Europa's vents would not be identical to Earth's. The composition would differ, the temperature profiles might vary, but the fundamental principle would be the same. Energy flowing from within the moon, chemical abundance, and liquid water meeting in ways that could support life of an unfamiliar kind. This is the thought that rests at the heart of Europa's quiet promise. Not that the moon is a duplicate of Earth, not that we might find oceans and islands and familiar landscapes, but that the basic requirements for life as we understand it, liquid water, chemical energy, and time, appear to be present in this alien ocean. Beneath the ice, in absolute darkness, in conditions that would seem utterly forbidding to any creature that has ever lived on Earth's sunlit surface, there might be ecosystems entirely unknown to us, entire worlds of warmth and activity invisible to any eye. The comparison to Earth's deep vents is comforting in a peculiar way. We do not need to imagine life adapted to conditions we have never seen. We only need to remember that such conditions already exist here, in our own world, and that life has learned to flourish in them. Europa's ocean floor, warmed by the slow friction of tidal flexing, bathed in minerals leached from the rocks, stands as an almost perfect analogue to environments we know sustain life. The difference is merely one of scale and perspective. A world ocean instead of scattered vents, ice above instead of an atmosphere, Jupiter's vast shadow instead of Earth's sky. What you're seeing in those first close photographs, those grainy images sent back across the solar system in the late 1970s, is a canvas of ancient storytelling written in ice. The surface of Europa is not smooth, not featureless. It is instead a tapestry of lines and ridges and fractures that seem to tell a kind of slow, patient geography that nothing on Earth quite resembles, though some places come close. These are called linea, a name borrowed from the language of classical astronomy, and they stretch across Europa's pale face like some enormous calligraphy that we're only beginning to learn how to read. Picture, if you will, what happens when you freeze water on the surface of a sphere and then pull it from beneath. The shell itself must expand and contract, must crack and shift, and those cracks don't disappear. They fill with material from below, they freeze again, they widen. Some of these linea are thousands of kilometers long, sweeping across the moon's face in gentle curves and sharp angles, bright in some places, dark in others. The darker ones, scientists believe, may be stained with the oxidized minerals and organic compounds that exist in the ice itself, or perhaps carried up from the ocean below during moments of upwelling. When you look at these photographs in sequence, watching the Voyager spacecraft sweep past and then the later, closer images from Galileo returning to us across the void, You begin to sense a kind of slow violence occurring beneath the frozen skin. Nothing catastrophic, nothing sudden, but a grinding, patient reorganization of matter. There are places on Europa where this process becomes even more pronounced, where the surface seems almost turbulent, almost chaotic. These regions are called chaos terrain, and they represent some of the most visually arresting and scientifically perplexing features on the entire Moon. In these zones, the ice appears jumbled, broken into blocky fragments that seem to have been jostled and rearranged, almost as if someone had taken the smooth, cracked shell and shaken it gently until the pieces no longer fit together in their original pattern. The blocks are sometimes tilted at odd angles to one another. There are ridges between them, subtle mounds where the fragments overlap or pile. These areas are typically younger in geologic time, meaning the chaotic disruption happened more recently than the ancient, heavily cratered terrain of other moons. Though recent in this context can mean anything from a few 100 million years ago to perhaps 1 billion years in the past. What could cause such a thing? That's the question that has drawn planetary scientists into deep contemplation for decades now. One explanation that has gathered considerable support, though it remains suffused with uncertainty, involves a kind of sublimation and refreezing, water ice turning directly into vapor and then recondensing within a relatively narrow zone. This could happen if the ice itself is warmed from below, if thermal energy from the tidal heating deep in Europa's rocky interior rises up and destabilizes the lower portions of the shell. Another possibility, one that's equally fascinating, involves the eruption of water onto the surface. Cryovolcanism, not the violent spewing we associate with volcanic activity on Earth, but rather a slow upwelling and freezing of water and slush that can reshape the topography. When you look at the images of chaos terrain, you're potentially looking at the fingerprints of that process, the signature left behind by water that moved upward toward the light and then froze in place. The ridges themselves, and here we must linger a moment with what scientists call double ridges, for they are among Europa's most distinctive features. These are structures that appear as twin peaks with a valley between them, and they can stretch for hundreds of kilometers across the surface. How they form is a matter of hypothesis and careful observation, rather than absolute certainty. But the prevailing idea is this: water beneath the icy shell pushes upward through a crack or weakness. It doesn't quite reach the surface. Instead, it freezes within or just below the uppermost layers. As it freezes, it expands slightly, pushing the overlying ice upward, creating that characteristic ridge pattern. Over time, as more pressure builds and more water is added, the ridge can grow higher, can become more pronounced. Some of these features appear to have been reactivated multiple times, as if they were ancient scars along which the subsurface ocean continues to press, continues to reach upward, continues to leave its mark. There's a particular beauty in imagining this, in lying with the thought of it, beneath a crust of ice several miles thick, warmed by the relentless kneading of Jupiter's gravity. A global ocean churns and stirs. It is not still, it is not inert. It presses upward against every weakness, every crack, every ancient scar, and in doing so, it leaves a kind of faint writing on the surface above. The linear are like words in that language. The chaos terrain is like a paragraph where the ice has been scrambled, rearranged, as if the ocean itself has been speaking more urgently. The ridges are like repeated passages, returning again and again to certain themes, certain cracks, certain conversations between the hidden water below and the frozen crust above. And what fascinates researchers is that these surface features change over time. When you compare images from Voyager in the 1970s with those from Galileo in the 1990s, and then with observations from Earth-based telescopes and space missions today, you can see that some of these linear appear brighter, Some appear to have shifted slightly, some seem to be in the process of formation even now. This suggests that the ice shell of Europa is not a static, unchanging dome, but rather a dynamic system, one that is actively responding to the forces working beneath it. The ocean is not simply sitting there, preserved in isolation like some ancient specimen in amber. It is alive in a physical sense, moving, responding, pressing against its boundaries, leaving traces of itself on the world above. How deep does this process extend? How far down into the ice does the influence of that subsurface ocean reach? These are questions that remain only partially answered, suffused with the kind of elegant uncertainty that characterizes the exploration of distant worlds. What we can say is that by reading the linear and the ridges, by studying the patterns of chaos terrain and comparing them across Europa's surface, scientists have begun to construct a picture of an ice world that is far more dynamic than it appears at first glance. Beneath that pale, fractured surface lies a churning, hidden geography, one that may be far more complex and intricate than even the most imaginative theoretical models have predicted. And that is where we find ourselves, standing at the edge of understanding, peering at a moon that continues to hold its deepest secrets just out of reach. Beneath that pale, fractured shell, where pressure and darkness have ruled for billions of years, something remarkable occurs in the thinnest layer imaginable. Europa possesses what we might call an atmosphere, though calling it that feels almost generous. It is so tenuous, so gossamer thin, that if you were standing on that frozen surface, you would feel nothing at all. You would breathe your suit's recycled air and perceive only the absolute silence and cold. And yet this delicate veil exists, and it tells us something profound about how a moon caught between darkness and radiation has learned to breathe. The oxygen there does not come from life or from chemistry we might recognize from Earth. Instead, it is born from one of nature's most elegant transformations. When Jupiter's intense radiation, cosmic rays and charged particles streaming through the vast magnetic field that envelops the planet like an invisible cathedral, strikes Europa's icy surface, something happens that seems almost impossible. The water molecules in the ice absorb this energy, and their bonds split. The hydrogen is knocked away into space, too light to be held by Europa's faint gravity. But the oxygen remains. It accumulates in microscopic amounts, layer upon layer, producing a gossamer atmosphere composed largely of oxygen that is, quite literally, manufactured by the cosmos itself. Scientists estimate that this thin exosphere contains somewhere in the range of 100 million to a billion molecules per cubic centimeter. If you tried to measure it with the instruments we use to gauge Earth's air, you would find it nearly invisible. The pressure at Europa's surface is roughly a trillionth of what we experience here on our world. To find an equivalent thinness on Earth, you would have to ascend far beyond the edge of space, into regions where satellites orbit, and the atmosphere has already surrendered almost entirely to the void. And yet there it is, a ghostly presence, reminding us that even in the harshest corners of the solar system, chemistry finds a way to persist. What makes this atmospheric manufacturing process particularly soothing to contemplate is its constancy. Day after day, year after year, over vast stretches of geological time, Europa's surface is being slowly worked by radiation, and in that grinding work, oxygen is being liberated. It is not a violent process. It is patient, almost meditative. The radiation falls, the ice transforms, the oxygen gathers. There is something timeless about it, something that speaks to the slow patience of planetary processes that operate on scales our human minds can barely grasp. Yet the radiation environment that creates this thin oxygen is itself worthy of wonder and perhaps a little awe. Europa orbits within what scientists call the Jovian magnetosphere, a region so dominated by Jupiter's magnetic field that it has become one of the most intensely radiation-bathed places in our solar system, excluding the surfaces of the Sun itself. Jupiter's magnetosphere is enormous. If you could see it from Earth, it would appear in our night sky as an object many times larger than the full moon, a sprawling, invisible ocean of charged particles and magnetic force. And Europa, small and pale and quiet, orbits within that maelstrom. The radiation comes from many sources. Cosmic rays arrive from the distant reaches of the galaxy, having traveled unimaginable distances through the dark. But the most intense radiation near Europa originates from Jupiter itself. The planet's enormous magnetic field, generated by currents deep within its interior, captures and accelerates particles stolen from the solar wind. These particles become trapped in radiation belts that surround Jupiter in much the same way that Van Allen belts surround Earth, except that Jupiter's belts are far more intense, far more energetic. They hold particles moving at nearly the speed of light, and when these particles rain down upon Europa's surface and upper atmosphere, they carry tremendous energy. It might seem that such an environment would be hostile to any kind of existence, and in many ways it is. An unprotected human exposed to Europa's radiation environment would receive a lethal dose in hours rather than days. The charged particles would tear through cellular structures, damaging DNA, disrupting the delicate machinery of life. And yet, and this is where the meditation deepens, this same harsh radiation is also a creator. It breaks apart water ice and creates oxygen. It energizes chemical reactions. In a curious way, Europa's danger is also its gift, its curse, its sustenance. The magnetosphere around Jupiter is not static or unchanging. It fluctuates, it compresses and expands. Solar wind gusts push against its outer boundaries, while currents deep within the magnetosphere itself generate waves and disturbances. Europa, in its slow orbit, passes through regions of varying intensity. There are moments when the radiation flux increases, when the flux tubes, those invisible highways of charged particles that connect Jupiter to its moons, shift and intensify. There are quieter periods when the radiation subsides to baseline levels that are still extraordinary by any human measure, but slightly less extreme than the peaks. The interaction between Europa and this magnetic environment is not entirely one-sided. The Moon itself, with its salty subsurface ocean and its conducting interior, generates its own subtle magnetic field. This field interacts with Jupiter's magnetosphere, creating perturbations that scientists have learned to detect and measure. It is like watching a small stone disturb the surface of a vast, invisible sea. The Galileo spacecraft, in its patient orbits during the 1990s, measured these magnetic disturbances and found evidence not only that a subsurface ocean existed, but that it was composed of salt water that conducts electricity, salt water that responds to magnetic fields. In this sense, Europa's atmosphere and the radiation that creates it are intimately bound to the ocean below. The oxygen generated at the surface rains down through the ice, penetrating tiny cracks and micropores, eventually reaching the hidden waters beneath. There, that oxygen might drive chemical reactions with minerals on the ocean floor. There, it might provide energy sources for hypothetical microbial life adapted to such extremes. The radiation that sculpts the magnetosphere and bombards the surface is simultaneously poisonous and generative, destructive and creative. The beauty of contemplating Europa's thin atmosphere lies, perhaps, in recognizing these paradoxes and allowing them to exist without resolution. A place can be lethal and nurturing. A force can be violent and essential. A moon can exist in terrible isolation and yet be woven into the vast energetic fabric of its planet's magnetosphere, never truly alone, always connected, always being shaped and reshaped by forces of almost unimaginable scale and subtlety. And in that thinness, in that delicate veil of oxygen molecules scattered across a frozen moon, we find something quiet and persistent and somehow deeply right. And yet the most profound question of all remains not answered, but whispered across the darkness between worlds. Beneath Europa's fractured ice, in waters that have never known sunlight, could something be alive? Not in the way we imagine life, perhaps, but alive nonetheless, in forms so foreign to us that we struggle even to frame the question properly. Here on Earth, we have long believed that life requires the sun. We imagine green plants reaching toward warmth and light, animals grazing in meadows bathed in golden rays, the whole of existence somehow threading back to that fundamental source of energy and heat. But in the deepest trenches of our own oceans, where no light has ever reached, we have discovered entire ecosystems that thrive on something altogether different. At hydrothermal vents miles beneath the surface, hot mineral-rich water erupts from the planet's interior, and in that darkness, in that heat, life flourishes. Bacteria and archaea, simple and ancient forms of life, draw their energy not from the sun, but from the chemical reactions themselves, from the meeting of superheated water and the cold ocean around it. These creatures are called chemosynthetic, and they have taught us something humbling. Life does not require the sun. It requires only energy, liquid water, and the chemical elements that make up the living world. Now imagine such a vent system, but not on Earth. Imagine it far below the ice of Europa, where tidal heating has melted stone and water into an ocean warmer than it should be. The physics is the same, or should be. Jupiter's gravity needs Europa's interior, flexing the moon's rocky heart, and that friction generates heat that could warm the water from below, could create the very conditions that foster life in Earth's lightless depths. The water there would be salty, rich with minerals leached from rock. There would be chemical energy, there would be liquid, the basic recipe, rendered in a language that life might understand. This is where astrobiology enters the story, carrying with it both caution and wonder. Astrobiology is the study of whether life could exist elsewhere, how it might arise, what forms it might take. It is a young science, perhaps still finding its footing, yet it asks questions that humans have dreamed about for millennia. And with Europa, astrobiology finds itself face to face with something that looks, on paper, almost hospitable. Almost. The creatures we call extremophiles have shown us the outer edges of what life can endure. There are bacteria that live in boiling hot springs, in water so acidic it would dissolve our skin, in environments frozen solid beneath the Antarctic ice. There are organisms that survive doses of radiation that would kill most living things 1,000 times over. There are archaea that have been revived from dormancy after being trapped in salt crystals for millions of years. They were, quite literally, asleep in stone, waiting. Life, it turns out, is far more flexible in its demands than we once imagined. Some researchers have wondered whether extremophiles could not only survive, but actually thrive in an ocean like Europa's. The cold is no barrier. We have found life in the coldest places on Earth. The darkness is no barrier. The deep oceans prove that. The pressure would be intense, certainly, but some organisms on Earth already withstand pressures that would crush most creatures instantly. And if Europa has hydrothermal vents, if it has those chemical reactions playing out in the dark water, then the energy source is there. The building blocks are there. The conditions, at least from a distance and with all the caution such speculation deserves, begin to seem almost plausible. Yet here is where we must be gentle with ourselves and honest. We do not know if Europa's ocean actually exists. We have very good reasons to believe it does, based on magnetic field measurements and gravity data, but we have not seen it. We do not know if it has vents or if it is entirely still and cold and barren. We do not know if the chemistry there would be anything like Earth's chemistry, or if it would be somehow forbidding to any form of life we might imagine. We are, in a very real sense, trying to answer the deepest question humanity can ask, while standing on one side of a great wall of ice, unable to see through to the other side. There is also the matter of time to consider. Europa has existed for 4.5 billion years, orbiting in Jupiter's shadow, its ice cracking and reforming, its buried ocean endlessly stirring. That is an almost incomprehensible span of time. On Earth, life arose relatively quickly, in geological terms, within the first few 100 million years. If Europa's ocean has existed for even a fraction of that 4.5 billion years, there would have been time. There would have been vast expanses of time in which simple chemistry could become something more, in which the dance of molecules could organize itself into patterns that we would recognize as alive. But would it? That is the question that keeps astrobiologists awake, and that should perhaps keep us gently wondering as we drift towards sleep. We have only one example of a living world, and that is Earth. We know that life arose here, and it arose with what seems like almost stubborn inevitability, filling every possible niche, evolving into forms of astonishing diversity and complexity. Does that mean that life is a common outcome of the right conditions? Or is Earth so profoundly lucky, so privileged in its particular arrangement of atoms and chance, that life here is almost a miracle, something that should not be expected elsewhere? Europa poses that question with quiet intensity. It is close enough that we might one day know the answer. The instruments are being built, the missions are being designed, and yet Europe remains, for now, a profound unknown, waiting beneath its ice with a patience we can barely fathom. It was in the year 2024 that humanity assembled a spacecraft built not to answer the grandest question, but to listen carefully to the quieter one. The Europa Clipper mission, named with elegant simplicity for the way it would clip past the moon repeatedly without landing, represents something almost paradoxical in the architecture of space exploration, a mission designed with patient uncertainty as its guiding principle. Rather than racing toward a singular, dramatic discovery, the Clipper was engineered to move slowly through time and across Europa's face, gathering whispers of data, building a portrait of habitability piece by piece. The spacecraft itself is a study in thoughtful constraint. It weighs approximately 2.5 metric tons, and yet its instruments span a careful symphony of sensors designed to read Europa like a page written in ice and electromagnetic fields. There are cameras that will image the surface at resolutions finer than anything humanity has achieved before, allowing scientists to study the texture of chaos terrain, the branching patterns of ridges, the subtle darkening of ancient scars. There are spectrometers that will pass the wavelengths of reflected sunlight, discerning the chemical composition of Europa's icy crust with a precision that feels almost like reading molecular handwriting. And there are instruments designed to sense the invisible, a magnetometer to detect the subtle disturbances in Jupiter's magnetic field caused by the hidden ocean below, a radio science investigation that will measure the gentle tug of gravity as the Clipper passes overhead. The journey to Europa is itself a meditation on time and distance. Launched from Earth with a trajectory that seems to spiral outward before folding back inward, the Clipper will travel approximately 5 billion miles before it reaches its destination. Along the way, it performs a delicate dance with the Sun and the gravity wells of other worlds, using Earth itself as a gravity assist in its intricate path. The spacecraft will not arrive at Jupiter for several years, and when it does, it will not immediately settle into a stable orbit around the gas giant. Instead, it will enter into what mission planners call a capture orbit, and from there, It will begin its patient series of flybys, approaching Europa at closest pass ranges, measured in hundreds of kilometers, then pulling away to gather data from distance, then returning again. This rhythm of approach and retreat will be repeated dozens of times, each passage an opportunity to gather observations that cannot be seen from a single vantage point. What makes the Europa Clipper's purpose so philosophically elegant is what it is designed not to do. It will not land, it will not drill through the ice, it will not descend into the ocean to search for microbes or evidence of metabolism, or any of the signatures we associate with life as we understand it. Instead, the mission carries a more refined ambition. It will map the conditions of habitability. It will answer the question of whether, in the depths of Europa's ocean, the fundamental requirements for life as a chemical phenomenon might exist. What is the temperature of the water? How does heat flow through the rocky interior? Is there a source of chemical energy that organisms might exploit? How is the ocean connected to the surface? Does material from above reach down below, and does material from below escape upward? These are the questions the Clipper will pursue with the patience of a scholar reading an ancient text. The design philosophy reflects something important about how we now think about exploration beyond Earth. There is no grand finale planned, no triumphant moment of discovery or disappointment. Instead, there is the quiet accumulation of understanding. The Clipper will orbit in what amounts to a long, looping ellipse, approaching Europa repeatedly across several years of mission operations. Each pass will add detail to the maps already forming, will refine the models of internal heat and ocean circulation, will challenge or confirm the theories built up over decades of remote sensing and mathematical speculation. It is the opposite of a treasure hunt. It is more akin to the patient work of a naturalist, spending seasons in a landscape, noting what changes and what remains constant, building intimacy through observation. There is something deeply soothing about this approach to discovery, a recognition that some questions cannot be rushed. Europa will reveal itself gradually. The ice will show its scars and fissures and subtle colorations, and from these impressions we will infer the movements of the ocean beneath. The magnetic field will betray the presence and composition of the conducting fluid hidden below, and from these whispers we will deduce something true about the world's internal engine. The Clipper carries no life detection instruments because life, as it exists on Earth, is not what the mission seeks to confirm. It seeks instead to answer the prior question, is this a place where life could possibly exist? And that is a question that patience and careful observation can answer without ever opening a door to the ocean's depths. There exists a possibility, one that has haunted the imaginations of planetary scientists in recent years, that Europa does not simply sit in silent, frozen stillness, but rather breathes. Not as we breathe, with lungs and conscious intention, but in great plumes of water vapor that periodically erupt from cracks in its icy crust, as though the moon itself were exhaling after holding its breath for eons. The idea arrived gradually, first as a whisper in the data. When the Hubble Space Telescope turned its gaze toward Jupiter's system in the early 2010s, astronomers were looking for ultraviolet signatures of hydrogen and oxygen, the molecular remnants of water molecules that had been ionized and scattered by the intense radiation surrounding Jupiter. What they found was tantalizing and uncertain, fleeting hints of an absorption pattern that suggested plumes rising from Europa's south polar region. Not a certainty, never quite a certainty, but a compelling suggestion that something was rising from beneath that pale, cracked shell. The uncertainty itself becomes a kind of poetry when you sit with it. These detections were sporadic, inconsistent across observations. Sometimes the signal appeared strong and clear, other times it vanished entirely, as though Europa were hiding its breath from us, playing an ancient game of reveal and conceal. The scientific community responded with careful skepticism and careful hope, two emotions that can coexist perfectly in the heart of someone who has devoted their life to studying distant worlds. Some researchers argued that the observations were real, that Europa's subsurface ocean was indeed venting its contents into space. Others suggested that the signals might be artifacts of data processing, or that hydrogen and oxygen in the Jovian system could originate from other sources entirely. And yet, there is something deeply resonant about the concept itself. If Europa does produce these plumes, what would it mean? Consider, for a moment, the physics at play. The subsurface ocean beneath Europa's ice shell is kept warm by tidal friction, by Jupiter's immense gravitational hand squeezing and releasing the moon's interior in a slow, rhythmic kneading that generates heat from friction. In certain locations, particularly where the ice crust is thinnest, perhaps in regions where cryovolcanism has created fractures and weaknesses, that warm water might rise. It would encounter the frozen ceiling above, and some portion of it would vaporize, expanding with tremendous force, forcing its way through cracks to burst into the vacuum of space. There it would freeze almost instantaneously, forming plumes of ice crystals that climb hundreds of kilometers above the surface before spreading and dissipating into the thin magnetic fields and charged particle environment that surrounds the moon. From the perspective of the subsurface ocean itself, this would be a kind of breathing, an exchange of matter between the hidden depths and the hostile surface above, a way for the warm, chemically rich water of the ocean, the water that might contain heat vents and the molecular building blocks necessary for life, to reach the radiation-bombarded surface of the moon, where those chemical signatures could be detected, collected, and analyzed by spacecraft passing nearby. The Hubble observations, tentative as they were, took on a different character in light of this understanding. They were not merely data points in a spreadsheet. They were potential messages from a hidden world. They suggested that Europa might be actively revealing itself, layer by layer, exhale by exhale, to those patient enough to listen and look. In the years that followed, other instruments sought to confirm or refute these plumes. The New Horizons spacecraft, during its 2007 flyby en route to Pluto, collected data but found no decisive evidence. Ground-based observations continued, yielding mixed results. By the time the Europa Clipper launched on its long journey to the Jovian system, the plume question remained beautifully, frustratingly open. No one could say with absolute certainty whether Europa exhaled or remained silent. And perhaps, in the vast landscape of deep space exploration, where so much remains unknowable until we draw near enough to touch it, this state of productive uncertainty is exactly where the most interesting questions live. There is something calming about uncertainty of this variety. It is not the anxiety of the everyday unknown, but rather the gentle mystery of a world that will slowly reveal itself to those patient and curious enough to wait. The plumes, if they exist, are not going anywhere. Europa orbits Jupiter in its thin shell of ice, and that subsurface ocean churns beneath, driven by forces that have been at work for billions of years. The plumes, real or not, suggest that the moon is not a dead, static object, but a dynamic place where the deep and the distant constantly exchange with one another. And so the question remains, hanging in the darkness between words, does Europa breathe? The answer will arrive in its own time, carried back to us on signals traveling from one of the most alien and mysterious places in our solar system. Until then, we can imagine it, the vast ocean far below, the pressure of water against ice, the gathering of warmth and chemical energy, and then, in a moment both violent and beautiful, the release, the exhalation of a world that has been holding something precious in its depths, finally letting it rise toward the stars. And so we arrive at the place where all journeys through Europa must eventually settle, not in conclusion, but in contemplation. For this distant moon, orbiting in the dark beside the giant it can never escape, has become something far more than a target for probes and spectrographs. It has become a mirror for the deepest human impulse to wonder what lies beneath, to imagine presence in the most unlikely and hidden places. Think of Europa as you might think of mystery itself, not the kind that demands immediate solving, but the kind that asks you to sit with the question, to hold it gently, the way you might hold a smooth stone worn by an invisible ocean. The ice shell that covers this moon, that pale, cracked surface we have studied now for decades, is not a barrier, it is an invitation. Beneath it churns a world of water and salt and pressure and heat, and no human eye has ever seen it. No rover has ever rolled across its ocean floor. We know of Europa's depths only through mathematics, through the faint whispers of gravity and magnetism, through the patient logic of science, conducted from billions of miles away. And there is something restful in that distance, something peaceful in not knowing. The universe has hidden most of its secrets far from us. We live on the surface of one small world, and even here, in our own oceans, we have explored less than 10% of what exists below. Europa reminds us that this reaching, this yearning, this careful accumulation of knowledge, piece by piece, it need not be rushed. It can be slow, it can be patient. The Europa Clipper will not arrive for answers in a season or a year. It will arrive in time, and in time it will observe, and observation itself is a kind of peace. There is also something deeply human about what Europa represents to us. We are creatures of surfaces and depths. We live between the known and the unknown. We fear the darkness, and yet we are drawn to it, pulled toward it, the way we are pulled towards sleep itself. Sleep, too, is an ocean. Sleep, too, is a mystery that we enter every night without full understanding of what we will find there, without maps or guarantees. And Europa, in its quiet orbit, teaches us that mystery and safety can exist together, that wonder does not require immediate resolution, that some of the most profound questions can be held suspended in the mind, like a suspended animation, like a sleeper suspended between waking and dream. Consider what we do not know about Europa. We do not know whether its ocean is alive. We do not know the shapes of its underwater mountains or the chemistry of its deepest vents. We do not know whether tides pulse through its ice with rhythms we could predict or rhythms that would surprise us. We do not know if water plumes break the surface on the night side of the moon, invisible to our distant instruments, breathing into the vacuum with no witness but the stars. We do not know if the ice is smooth in places or if entire regions remain unmapped in our minds. And this not knowing is not a failure of science. It is a promise. Every blank space on a map, every mystery that remains unsolved, every question that leads only to deeper questions, these are the places where curiosity can rest. Not rest as in stopping, but rest as in settling into a state of gentle, ongoing wonder. Europa exists in that state. It has existed that way for billions of years, and it will continue to exist that way, turning in its orbit, keeping its secrets, inviting us to wonder. There is a kind of ancient quiet to Europa, the kind of quiet you might find in a deep forest that has never been entered, or a cave beneath the earth that has never seen light. It is not the quiet of absence, but the quiet of presence so deep and so patient that it seems like stillness. Jupiter hangs above it in the sky, massive and swirling, and Europa continues its slow orbit, continues its dance, continues to turn. The tides rise and fall within its hidden ocean. The ice cracks and refreezes. The radiation from Jupiter's magnetosphere paints the surface with energy, and through it all, Europa remains itself, a small, pale, mysterious world that asks nothing of us except that we pay attention, that we stay curious, that we do not look away. What does it mean to have a heart that you cannot see? Europa teaches us this. The moon itself is a heart, beating with tidal forces, warm with internal heat, full of motion and chemistry, and perhaps, in its depths, with something we might recognize as life. But we cannot see this heart. We can only infer it. We can only trust in the mathematics, the measurements, the slow accumulation of evidence that points toward an invisible ocean. And there is tremendous peace in this, in learning to trust what we cannot see, in becoming comfortable with the limits of our vision. As you drift now, let Europa drift with you. Let it move through your mind the way it moves through space, slowly, steadily, orbiting its great master, keeping its mysteries close. The ice is cold and smooth and ancient. The ocean beneath is dark and full of possibility. The surface cracks are writing in a language we have only begun to learn. And somewhere in that darkness, there may be vents that bloom with heat. There may be creatures that swim in darkness and never see the sun. There may be ecosystems that operate on principles we have not yet imagined. Europa does not ask us to solve it tonight. Tomorrow, another mission may arrive. Another year, another discovery may shift our understanding. But tonight, Europa asks only that we rest with the mystery, that we hold the question without urgency, that we allow ourselves to wonder, and in wondering, to feel the same peace that an ancient moon must feel, orbiting through the dark, keeping safe what lies beneath, patient and present and whole. Let Europa be your guide now into the darkness. Let its slow orbit become your own slow descent into sleep. The mysteries will still be there when you wake. The ocean will still be hidden. The ice will still be cracked with patterns we are only beginning to read. And there is comfort in this constancy, in knowing that some mysteries choose to remain mysteries, and in that remaining, they offer us something precious, an endless reason to wonder, an endless permission to be still.